Okay, here we go. Okay, so yeah, you don't have the notes? Oh. Oh yeah, I know. Okay. Well, okay. I got the itch to bake yesterday, and you guys missed out on it. But don't worry, I'll take care of you guys. Yeah. You know what? I will do cookies. How about that? I can do brownies too. How about both? How about both? Okay. Everyone wins. All right. Next week, I'll book the hearth and I'll bake for you guys. Okay. It's all good. Okay. What kind of cookies do you guys like? Any nut allergies or gluten? You have a nut allergy? But you have an allergy?
Almost every nut, but
Okay. Well, then brownies could work. Brownies probably could work then. Okay. You have an allergy too? Okay. I'll be mindful about that. Um, okay. So let's move on. Okay. But I'm glad people are talking about it. That's good. Okay. So, all right. So the muffins had an impact. That's good. All right. So, but don't worry, I'll take care of you guys. All right. So we're gonna talk about properties. James squared. Thanks. Okay, let's focus. All right. Good. I like that. All right. All right. So properties. So when we're dealing with proofs, we have to understand properties. Now, these properties are going to be pretty obvious, but we have to be formal when we state them. So you can see like the stuff on the wall there, those like proofs from my unit class last year. We're going to be working on that kind of stuff. So pretty obvious if these two letters equal each other. If you add the same thing each side, of course it's going to say equal, right? Like if I add, like for example, like let's say I add 4 to A and to B. Great. A plus 4 equals B plus 4. Well, if that's true, if A had equal B initially, right? So we call that the additional property of equality. So you're adding the same thing to both sides and maintaining the equality. Likewise, if I subtract the same thing from each side, that's true too. If I multiply the same from each side, that's true. If I divide by both sides, great. So these are all called properties of equality, but depending on what operation you're using, addition, subtraction, multiplication, division, right? Substitution is a big one. That means just replace. Hey, like A equals B, or in this case here, X plus Y equals 5, X equals Y, then guess what? I replace Y with X. That's true. Or replace X with Y. That's true. You're just substituting. So that's a property we use a lot. The next one is kind of a Captain Obvious or very duh kind of moment. If something equals itself, well, of course it equals itself. Of course A equals A. There are times where we will need to do that from geometry, that you'll see why we need to do that. That's called the reflexive property because it's a reflection of itself. It sees itself in the mirror. If you decide to reverse it, we call it symmetric. We really rarely use that one. There's a transitive property that A equals B and B equals C, then A equals C. It's kind of substitution personally, but it's kind of like saying if the 49ers beat the Seahawks and the Seahawks beat the Rams, and the 49ers should beat the Rams. It doesn't work that way then. But it's kind of like that's what it's saying. It's kind of like that. If you distribute, you guys should know that. That's pretty obvious. Congruence. Um, these are other ones. So we actually call this definition. No, it's just a definition of congruence. Actually, hold on. Let me get my filled out notes because I might actually be watching this right now. Hold up notes right here. Actually, I was wrong. Whoa, I was wrong. That what was right. What was correct? These are properties of congruence. Sorry, but I had the wrong. You're right. This is reflexive. You're 100% correct. Thank you for catching that. Now, if I were to say this, reflexive, reflexive. You don't have to lay it all on the line sometimes. You could, partial effort's fine. Okay. If you just reverse it, it's called symmetric. And if you're saying one thing equals this, another thing equals this, then these equal each other, we call that transitive. But substitution is okay as well. And that's angle P. If P equals C, C equals G, then P equals G. So just to be clear what I wrote, I'll just for maybe mistake earlier on, that's reflexive. Something equals itself, it's called reflexive. If you decide to just reverse order, it's called symmetric. If one thing equals something and that something equals something else, then those two things have to be equal. We call that transitive, or you could say substitution. Substitution is totally fine because you are substituting. I am replacing YZ here with X1, or replacing angle C with angle B. I totally can do that. Okay, so these are lists of properties. And actually, I'm gonna give you guys an extra packet. If you want, it's an optional packet. This is just if you're looking for like a cheat sheet, like a reference that you can use on a test. No, let me double check with Mrs. Perone did teach this class last year, so let me double check. I don't know. I know at level Geo we did. I'm not sure what the expectation for Geo honor, so let me find out. I'm not 100% sure. Yeah. I don't know yet. I don't know. Yeah. So let me, but at least this is something to study from, right? So I'll provide this for you guys as well. At least you have access to it at home. All right. So we're ready to do our first proof. Okay. So any algebra question that you solve is actually a proof, believe it or not. But there's a formality where we're going to state the reasons for each of these steps. So for example, I mean, we'll just talk it out, right? Like if I ask you to solve this, well, I think most likely you distribute, right? Then you probably combine my terms. Then you probably divide by whatever's in front of X, and then you have your answer, right? Yeah. So that's pretty obvious. Like, yeah, you distribute. Looks like we combine my terms.
Actually, wait, I divide by 2.
You can do that too. If you want. It's up to you. But let's follow what we see here. But you'd have to make that statement if you want to do it. And by the way, there's no perfect way to do this. Like there's not one way to do it, like several ways you can do it. But what's the first step? Well, before that, it was given. That was provided to us. Then, right, we did distributive property. I'll just abbreviate. Then it looks like we combined the two x's. So I did the subtraction. Property of equality. Then it looks like I did more. Yeah, because it looks like I had to subtract 2x here. But here I'm adding 14. So that's addition property of equality. Then it looks like I divide by 2. Division property.
No.
And the sixth one's kind of dumb because you already solved it, but since they reversed it, I mean, just symmetric property equality. I mean, I personally don't care about that, but just so if you're given these steps, what are the reasons to back up these steps? That's what I want you guys to get good at.
That's like Charlotte.
Okay, you gotta chill on the test, dude. It's like, dude, seriously, it's like 3 weeks from now. I'm worried about today. Today is my focus. I know hopefully tomorrow's a good day too, but I can't tell you 3 weeks from now. So we'll talk later. Okay. I have no clue. All right. Okay, we're good on that. So anyhow, but yeah, do those reasons make sense? Cool. Okay, let's keep going. Now we'll actually do more geometry stuff. So that was your first proof. Okay, so the 2-column proof. Typically, the first step's gonna be given. Oh, that's good. Given means it's provided to you. It's the first step.
You guys look at it?
Yeah, exactly. Yeah. Yeah, it's actually a free point. Actually, no one should ever miss the first one. It's a free point, just the given, the first step. Whatever is given to you in a diagram is given, just say it. That's it. And then usually the last step is what you're trying to prove. But the reason you're gonna have to come up with. But we're gonna have 2 columns, statements on the left, reasons off to the right. It's all about logic. So like what James was saying, like, hey, I want to divide by 2, that's fine. As long as your logic makes sense, it's totally fine. there's not like one exact way to do it. Some things that we did do in the last unit that we're going to utilize today and throughout this unit: segment addition postulate, angle addition postulate, definition of midpoint, definition of segment bisector, definition of angle bisector. And just so we're all on the same page, and because I'm lazy, so it's okay if you're lazy a little bit. If we use these abbreviations, I'll know what you mean. I'm not sure how to really abbreviate that one. You could say segment.
Yeah.
Here you could use a symbol. But you kind of need to write out the word bisector just so I know what you mean. But if you said midpoint, like MDPT, def, that's fine. SAP, AAP, I think those are valid abbreviations. Using a symbol, angle bisector, totally cool. Especially when we start getting the parallel lines. I'll tell you right now, when we get the parallel lines, you're going to really appreciate the abbreviations. Because to write these out over and over again does become very cumbersome. So we want to make sure we're like good vocab word, I know. Anyhow, we just want to make sure we're efficient, right? So now let's give the correct statement for each of these. I think we can go through this pretty fast. That's reflexive because it equals itself. No, that's if you are two different things that are reversed. If AB equals this and CD equals this, then AB equals EF. We call that transitive.
It's called trans.
That works. Symmetric. Substitution. Substitution works. Obviously, you're reversing, so that's symmetric. Now for D, what mathematical operation happened there to get that solution?
Subtraction.
Subtraction. And actually, I'm cool if you write like that. Because next up, what's the next thing I'm doing? Oh yeah, Lisa's good. Yeah, what's up? Subtraction's fine too. That's okay. What's the next one? Or you could write multiplication, or here you could write subtraction, as Lisa had just.
Subtraction property of equality, for subtraction, but then not for substitution or symmetrical.
For D?
Yeah.
No, the D because how you're solving it by subtracting 5.
Subtraction property of equality, but then for number B, you just have substitution.
Oh, B, we can say substitution for B also. We could.
No, but say, why don't you say property of equality? Is that only for
You can. I just didn't feel like writing it. I didn't feel like it. What's the next one for F, guys?
substitution?
Well, Z over 5 equals 10. And how are you solving for Z? So it's still multiplication again. Oh, wait. I messed up with E, guys. My bad. I messed up. My apologies. What was the hypothesis here? I thought it was a if Y equals. It's division. Yeah, my bad. F is going to be multiplication. Yeah, my apologies. Yeah, or you could write as division property. Or you could write this as multiplication property. So the X meant multiplication. That's what I meant by that. G should be pretty simple. What are you gonna say for G? Distributive. Next one. Wait, G is not division.
So let's
No, you're distributing for G. That's distributive. That's addition. Property of equality. Next step is you're replacing this with this, right? And No, because you're replacing both of them. So
Maybe
AB equals CD, CD equals EF, and EF equals 23. Yeah, substitution. Yeah, because what you're doing is you're replacing Correct. 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 Okay, let's keep on moving. Okay, now we got the proof. So I'm gonna work out one of these with you guys, and I'm gonna have you guys do the rest in groups and see how it turns out. We got a lot of proofs. Oh no, just whoever you sit next to. All right. Okay, here's the first thing we want to do. Talk this out. Always talk this out. Okay. We got two diagrams, right? You have angle 1, angle 2, and 3, angle 4. You're given some evidence. 1 equals 3. So 1 and 2 are constituted diagonal. So 1 and 2 are the same, 2 and 4 are the same. I think it's pretty obvious that angle ABC is going to equal DF. I think it's pretty obvious, right? Because
What is given?
1 and 2 are going to add to 3 and 4. But in order to prove it, there's a process, right?
Wait, one
So-
is given though, right?
Right. So the thing of this is a proof of training wheels. Ultimately, we're going to take these training wheels off. You're going to have to ride the bike on your own, right? But for now, I'll give you some training wheels, right? So that's given. If I add 1 to 2 and add 3 to 2,
It's an addition.
that's addition, right? And then I'm going to substitute because we're going to replace 2 with 4. So I'm going to substitute. So first off, that's going to be angle addition opposite because what I'm doing is that I'm adding the same, like you already know 1 equals 3, right?
Yeah.
So I'm adding the same thing to angle 1 and angle 3. So I'm adding angle 2.
It must be equal.
So that has to be addition proper equality. Then I'm replacing angle 2 with angle 4. That's substitution. Now, what do you think's happening with step 4? Well, 1 and 2 add up to the whole thing. 3 and 4 add to the whole thing. What do we call that? AEP, angle addition postulate. And then lastly, because 1 and 2 add is the same as 3 and 4, right? Because 1 and 2 is the same as 3 and 4. And you're told that 1 and 2 equals this, both 3 and 4 equals this. What do you think was that last angle? So 1 and 2. So let's back up a little bit here. Let's get a highlighter. This will help. Because this is the part where I don't want to lose people. So even though if you guys know the answers, just be patient. Let other people understand what's happening. So this is right here, right? And let's go green. Good. Yes. So it's pretty clear that the green has to equal the orange. So look at what's happening in orange, right? Orange is angle 1, 2. Angle 1, 2 equals what? ABC.
Oh, yeah.
Angle 3 and 4 is green. Angle 3 and 4 have to be up. So if these two are the same, aren't I just replacing this with the orange and replace this with the green, right? So of course, if ABC is 1 and 2, and DF is 3 and 4, if 1 and 2 is the same as 3 and 4, I'm replacing this with DF. I'm replacing this with ABC. Therefore, by substitution, those are the same. Does that make sense?
Yeah.
How I did that? Go.
What are you doing? Between steps 2 and 3.
So between 2 and 3, I'm substituting also. So the first one's given. Oh, we'll switch back to pen. So first one's given. The next one, because I added the same thing,
Addition.
so we already talked about that. We're good there. Then what I did was I replaced 2 with 4 because you told that from earlier. Does that make sense, Kayla? Yeah. Substitution. Then I did AAP. And then I did another substitution after that. Now, these proofs do get more challenging. And I do understand. I totally have empathy. And I'll total disclaimer. This is the only math class in high school I got to be in. I got an algebra trig honors as a freshman. I got A's in pre-calculus honors. I got A's in AP Calc 'cause I passed the AP exam. This is like class I got a B plus in because I hate writing. I totally despise. So I have empathy with you guys. Of course, I went to college. Of course, I did. UC San Diego for my undergrad. Yeah. I can't get in now. It's like so hard to get into that college, but anyhow. So yes, I did go to college. But the point I'm trying to make is that I have empathy with you guys. I understand that this can be a little painful to do. So what I'm trying to do, I'm trying to ease you guys into it. What I do care about are the concepts, understand conceptually how to connect the algebra to the geometry like we did in the last unit, but also just the logic, the logical flow, right? So I get it. I'm going to try to be as flexible as I can be. Like some of you guys are asking, do I have to write like it all out? Like, no, I'm going to be okay with like some of these substitutions. Like, you're not going to have to, you know, I'm gonna have some flexibility. That's the point I'm trying to make. Let's do one more together, and I'll have you guys do the other proofs in groups. Okay. All right. So again, triangles are still on, right? So take a step back. What's happening here? ST is the same as RN. Cool. Also, you're told that these are the same. So guess what? Those are going to be the same. I mean, that just totally makes sense, right? Like, well, duh, of course SI is going to be done. But there's a formality that goes into it. So given, there will be a SAT we'll have to do. We'll have to do some substitution, and subtraction. So let's write it out. SI and IT after the whole thing. What's that whole thing going to be called? ST, duh. RU as of DUN. What's that whole thing? RN, right? So here's the deal. Of course, SI plus IT. Oh, sorry, go ahead. Yeah, SAP. We got it. Same thing. What line? Oh, no, because we're saying the measures. We're not doing congruence. We're not doing congruence. I understand what you're saying, but we're not, yeah, don't worry about that. Hold on, let me undo that. Okay. Now, we already established that ST equals RN, right? From the given. So if ST already equals RN, aren't those pairs equal to each other? So that's a substitution. And since you already know IT equals RU, if IT equals RU, then I could just replace this with, let's do a different color so it stands out. I could replace this RU with IT. Let's get another substitution. And then because these are identical, what happens? How do you get away with you subtract it, right?
Yeah, but it doesn't say subtraction.
The last step does say that.
Oh, did it? Oh.
And we got proved. Got verified. Okay. So go ahead and try examples 5 and 6. Okay, I'll give you guys a few minutes to do that. We'll check in a moment. Try 5 and 6, see if you guys can prove it. And so we'll do some more after that. Okay. So go and try 5 and 6. I think we can finish all these notes today. So
Oh, the thing that this one is given. Yeah, yes, RS plus S, and RS plus P. That's reflexive, I don't know.
and I'll slowly reveal this to you guys.
And then you have like the again, you said that was enough. So it's like this.
Oh, yeah.
Yes. And now I think it's all into. And then we substitute the again.
All right, I'm gonna slowly reveal. Okay. So I'm gonna do a slow reveal for you guys. So RS equals PS. Okay, great. ST equals SQ, great. So of course RT is equal to PQ. Of course it is, right? But you have to prove it. So you have the givens. And then what do you think the second one's gonna be?
RS plus TS.
Okay.
Yeah.
Maybe.
Because you're adding the same thing. Or actually, you're just adding these two together, right? Because you're adding equal parts to equal parts. So another way to think about two traditional property of equality is that, like, say for example, that's kind of dumb. 5 plus 5 over. Of course, 5 plus 4 equals 5 plus 4, right? That's kind of what it's saying, right? Because you already know RS is right here, PS is right here, and then ST is right here, and SQ is right here. So you're adding two equal parts to other two equal parts. So that's still, you can still say that's segment, addition property of equality. So that's still valid. And then what do you think's gonna happen after that? Segmentation postulate, right? And by the way, you don't need to write them separate steps because they have the same reason. So you can combine these two in one step, right? So RS, of course, was RT. And what do you think the fourth one's gonna be, guys?
Substitution.
Substitution, there you go. So that's verified. Okay, keep going.
Postulate. Addition and substitution, property of equality.
So segment addition postulate is when two small things add to a big thing, based upon the diagram. The substitution is you're replacing one thing with another thing. Addition, you're adding the same thing to both sides of an equation. You're adding two equal parts to the same thing. Sorry, you're adding two equal parts to each side of an equation. Okay, are we cool with example 5? We're good with that? Okay. Example 6. Okay. So given. So this one, the training wheels are off, right? You guys keep moving. Training wheels are off. So next step. Always 3 points. I give a half point for statement 1, half point for reason 1. 3 point. Just to get it. It's very simple. Just put it down. Get a 3 point. Now, what we're trying to prove two other angles are equal. Angle 1 equals angle 3, right? Now, if AOC is the same as BOD, what two angles make up AOC?
Make up what?
What two angles make up AOC?
AB and BC. 1, 2. 1, 2.
What letters? Sorry, what numbers?
1,
1 and 2. What two angles make up BOD?
3, 2, 3.
2 and 3. Isn't 2 shared between both of these?
Yeah.
Okay. So this is where I think we're going to use a reflexive. I think we're going to use a reflexive in this case.
Measure.
Okay. So we should be okay with this, right? Angle 1 plus angle 2 adds to ABC.
To do like on the second one, why wouldn't we just do measure 1 equals measure 3? Like, how do we know when to do this?
I don't know that yet because we have to have some steps beforehand to make sense of it. So, like, this is pretty obvious. 1 and 2 adds up to AOC, right?
Yeah.
Just look at it. 2 and 2 add up to BOD. Just look at it, right? So let's just get out of the way. Because the diagram tells us that. So anything that is, I don't say obvious, but that you can extract from the diagram right away, put it down. Because now, if you think about it, we were given this. Well, we're given this. We use angle addition postulate, which we learned. You know, math is all about building upon itself. We learned about this previous unit. If these two are equal each other, what do you think my third step's gonna be, guys?
And angle 1 to 2
Equals
2, 3.
angle 2 plus angle 3. Okay, so what's the question? Yeah. So I'm gonna do substitution as my third. Each one that was beautiful. right? Because now I know that angle 1 plus angle 2 is added to angle 2 plus angle 3. Because if these are already equal, then these are equal. Now, this is the part that's kind of funny a little bit.
Division.
You-
Substitution.
Personally, I don't think we need step 4. I think that's kind of dumb. Yeah, I don't think we need this.
See?
I think this was personally unnecessary. I think we're just showing this to you just so you're aware you could say it. But you already have two things that are identical on each side. You just subtract it out. And then you're going to so I don't think step 4 is needed. But
No, but it could also be substitution because we know measure we could. Oh no, but then that would be measure 1 equals 1.
of course something equals itself, so we call it reflexive. I think personally I think it was unnecessary. But angle 1 equals angle 3. I think we go straight from 3 to 5, personally. Yeah, Jake, of course, yeah. But I think I could go straight from 3 to 5, 100%. I think we're okay.
Is class about to be over?
No, we still have some time still. Yeah, the 15 minutes, yeah. All right, let's keep moving, guys. Let's do you guys are gonna do it. You're gonna work it out. All right, go and do example 7 and 8 now. I think all these steps are relevant. So try 7 and 8 next. I'll show you guys in a few minutes. And then we'll do 9 and 10 to wrap up the notes. And this is good timing because it's exactly where I want to be. Yeah, that was the plan for today to finish off with good.
Where do you go for the measure?
That's reflexive.
Was that sorry?
Yeah. One goes to.
Actually, hold on a sec. Angle distribution policy runs that time to add up to something.
Number 4 should be 4.
So I would say angle 1 plus angle 2 adds up to each.
Right, so we do that before.
Actually, should
1
be
plus
each
2,
one.
I do.
And angle 2 plus angle 3 add up to
Yeah, so you just one.
so you're gonna so you have to have 2 angles, you have to have 2 angles after the big and then so let's say 1 and 2 adds up to this. Then what you're gonna do a substitution and then subtract.
Going to substitution.
Yeah, so for this next one.
Yeah, substitution. We have to take out 3 and 1. Don't we?
Which one do you want?
No, 3 should be angle addition postulate.
Yeah, that's.
Like, you have 3, so we should get that instead.
Yeah, so it's swap them.
Yeah, 3 is angle addition postulate. 4 is substitution.
Thank you.
Yeah.
Yeah, so yeah, Zoe, what's up? And then Yeah, so we have angle 2 equals angle 2. That's reflexive. 1 and 3.
Subtraction.
Width.
I just did.
Number 3 for this one right here. Well, we're adding the same thing.
choose 5. No, 3.
Personally, I would have done this.
Swap 3 and 4.
Yeah,
No. You
I would have said
we would do 2.
actually it wouldn't matter, but I personally would say 1 plus 2 equals DG. That's obvious. 2 plus 3 adds to HCF. That's obvious.
I think you don't have to do 3 though. I think you can go straight to 4. That would be.
Well, for 3,
the choice.
then you're doing a substitution afterwards, right? And that gets you the answer. Because you already know that 2 equals itself. So 1 and 2 adds to the DEG. 2 and 2 add up to. But you have to establish that 1 and 2 add up to 2 and 3. Yeah, you could have actually done step 3 where step 4 is.
Yes.
You could have done, yeah, it didn't have to be in that order. And also, I don't know if we really needed a reflexive, to be honest. I don't think we need step 2 because you're adding the same thing.
Just go down.
That'll be a substitution.
Wait, how is the substitution?
Because you're replacing one line with another line. What you're doing is that you already know. This is this, right? And this is this. So since those are equal to each other, I'm replacing this with EG. I'm replacing this with HEF. And substitute proper quality. Yeah, so that's example 7. So, but again, the 3rd and 4th steps could have been swapped. So if you had, so Ishan, I think you had like the 4th step where number 3 is, and vice versa. Yeah, so you totally could doesn't have to be exact in the order. Okay, for example 8. Yeah, James, yeah, I'll come back. No, I can't. I'll get in trouble.
I know like some teachers.
Yeah, actually, we all got in trouble yesterday. We're not supposed to. So yeah, there's no step. Yeah, sorry, I can't. Yes, it is bell rings, but honestly, the line goes fast and fine.
They say that, or like,
Well,
why?
it's still enough food. So example 7 are cool?
Yeah.
Okay. Now example 8, KP is the same as ST and PR is the same as TV. So yeah, of course those are gonna be the same, but that's gonna be a segment addition postulate. Yeah, so you got a given again. You're gonna add those equal parts to each other. Then you do segment addition postulate. You can skip what? No, we don't skip that. It's reflexive we're skipping over. No, because you have to show how you're gonna do the substitution in the first place, right? So here's the thing. And by the way, step 3 could be step 2. KP plus PR adds to the whole thing. PR, right?
Here, if I did step 1, KP equals ST, PR equals TV, and step 2,
Right.
SAP, KP.
Yes, good, yes, that's totally fine. But then afterwards, we do need to make a statement that if you add KP to PR and ST to Q, those are gonna be the same by addition proper equality. Because you're adding equal parts to equal parts, right? Yeah, go ahead. Yeah, you got, yeah. And then you substitute at the end. Yeah, you got, yep. We substitute at the end, right? Okay. Okay, you guys are doing fantastic. All right. I know. How do we substitute? Because what you're doing is that you already know that this equals this, right? What?
Yeah.
KP plus PR equals S plus T. What does KP plus PR equal? KR. What does ST plus T equal? SD. So you're replacing, right? This gets replaced with what? Think about it. This gets replaced with what? KR. This is replaced with what? SB. That leads into the last statements. It's a replacement, right? And that's what we call substitution. Okay,
Sucks.
I know, it's not fun. Last one, home stretch. Okay, example 9, guys, last page. And I'll show you the homework before you guys leave for lunch. And also have an extra packet if you guys just want extra practice. Or yes, I gave you guys more packet already. I did. I did give. What was that? On the homework, I'll post it to school. I didn't print it. I'll post it to school, Gene, so you guys have access to it. Okay. So what's happened in example 9? 1 equals 4. Great. Is 2 gonna equal 3? Well, let's talk it out. What do 1 and 2 add up to, guys?
180. Oh.
What does 3 and 4 add up to?
180.
There you go. So I'm gonna have to make that statement that 1 plus 2 adds to 180 because they form a linear pair. 3 and 4 add to 180, they also form a linear pair. You could probably use angle addition postulate too, I suppose. And then those equal each other, right? 1 and 2 have to add to 3 and 4. But because 1 and 4 equals each other, you could drop them out, leaving behind 2 equaling 3. So if we go through the process you have given, 1 and 2 after 180, 3 and 4 after 180. Personally, I like to say linear pair, because a linear pair meaning 2 angles after 180, but angle addition postulate's okay. So if these both equal 180, what do you think the third statement's going to be? What logically follows? This is why I care about the logic.
1 plus 2 equals 3 plus 4.
1 plus 2 equals 3 plus 4. 1 plus 2 equals 3 plus 4. Yes. Outstanding. And here's the deal. Didn't we establish that 1 and 4 were the same? Gotcha. Didn't we establish 1 and 4 were the same? Drop them out. How do you say it when you drop them out? Subtraction. So you're subtracting them.
Oh.
Now it's proven.
You subtract 1 and both sides, and 1 equals 4.
Because 1 and 4 are right identical, they just go away, leaving what behind? What we want to prove. So it's kind of like this undoing process in a way.
He goes to the next one.
10th, yeah.
What?
But hold on, are we cool? Well, let me take your what's question and just make sure generally everyone's fine with 9. Yeah, good. Mm-hmm.
I plus IT equals IT plus UN.
Yes,
So
yes.
then we cross out IT and IT on both sides.
Correct.
And that's
That was subtraction. It looks the same the way it's written, you know. Yeah. Yeah, the first few letters are the same.
Subtracted.
Oh, because these are identical. Because these are identical. Personally, probably if you want to be a little more formal about it, you could replace angle 4 with angle 1, and they have 2 identical things on each side, then you can subtract them from each other. But because I already know they're identical to begin with, just subtract them. It's fine. Okay, so Western asked about 10, right? All right. So AOI is the same as EOU, but what does AOI comprise of? 1 and 2. What does EOU comprise of? 2 and 3. And angle 2 is common to both, so we'll do a reflexive there, which they kind of get out of the way. So I did angle addition postulate because I established that AOI is the same as 1 and 2, EOU is the same as 2 and 3. And then because I know AOI equals EOU, then 1, 2 equals 2, 3. And because you have 2 and 2 identical on each side, you could drop it out, leaving with what you want to prove. And voila, you have your proof. You're all done. Amazing. Amazing. Good. Feel good. I mean, we're totally on pace. Actually, we're a little ahead of the game. Now, just so you know, homework is going to be, let me freeze the screen here. Homework is going to be this packet, which I already handed to you guys. If you somehow don't have it, please let me know. This is a homework packet for the entire unit. There might be one extra homework we'll do as a Delta Math. You're only going to do the first couple pages. So you do the part 2 homework. So you only do the first couple pages. Now, if anyone is interested in extra practice,
Just
just one page 1, 2. This is extra practice.
I don't need that.
You want?
Actually, I do, but I just.
Only one.
The first sheet, so yeah, so the first page one, that's right. One, yeah, that's it, yeah, go to the part two. I already did it. Alright, so wait till the bell rings, do not take off, whoa, guys, wait till the bell rings, you got 50 seconds.
Thank you.
50 seconds, just wait. Then you can probably read. Okay. Yeah, my class goes in the Wait. It's done. Right. Yeah, so.
Thank you.
Oh, you're welcome. Have a good day.